Hello there, and very warm greetings from the headquarters of the Forum for Agricultural Research in Africa, based out here in Accra, Ghana. It is my great pleasure to be a part of this epoch-making event on the occasion of the International Agriculture Innovation Conference holding in Taiwan, although in a virtual mode. Today, my subject is the application of artificial intelligence in agricultural digital twin. Again, my name is Yemi Akimbamijo, and I am the Executive Director of the Forum for Agricultural Research in Africa, based out here in Accra. So this is going to be my presentation plan. To start with, I'm going to give a short overview of FARA to make it as short as possible, and then I'll go on to the concept of digital twins and looking at some of the applications, and then zero down to the application of the digital twin concept in the agri-food sector. We'll therefore then look at some of the benefits, the challenges, and then a few recommendations before I conclude. A few words about FARA, ladies and gentlemen. FARA is the apex institution on the African continent that is responsible for the coordination of agricultural research, science, technology, and innovations. And FARA is also the technical arm to the African Union Commission and the African Union Development Agency, what we all know to be NEPAD. And we are also now the entry point, the point focal for all issues relating to global discussion on agriculture, and we are also having a very strong voice in the context of the global forums such as the G20, the G7, and in GFAR, the Global Forum for Agricultural Research. So our strategic goal is to contribute to the achievement of the AU member states Malabo Declaration on CAADP commitments, and also to drive these in the context of the Africa We Want Agenda 2063, which also automatically embraces the Sustainable Development Goals by 2030. Now, to move a little bit further, we have 4 strategic objectives: to enhance partnership, to promote access, and then to strengthen the agricultural research and development institutions, and then to strengthen the management of research, and to promote the coordination of continental initiatives. So this is how we perform our mandate. It is in a context of contributing to the achievements of the CAADP Malabo goals through the application of science, and there are the 4 thrusts and the underlying components that help us to really see how we can bring in the power of science in the context of science, technology, and innovation, and also co-create knowledge and capacity for development. Now, to the concept of the digital twins, it is what we know as the digital model of actual physical systems. In other words, 2 things coming together to serve a common goal. So we're looking at the intertwining solutions of complex system analysis, decision support, and technology integration. So the technology involves the collection of the real-world data and also to create simulations using integrated models. So these simulations will help us to provide decisions and also to accelerate life cycles and programs or services. Further, I'm going to speak a little bit more to the development and use of the digital twins that have been on the rise in the transformation agenda, and then we look at how digital twins and its applications provide different levels of control over the physical units and also help us to manage very complex systems. There are a few examples of digital twins. You find this in automotive engineering, in product testing. You find it in manufacturing, in training, You find it in sales, where you add the manufacturing capacities, and where companies have leveraged digital twins to simulate the impact and benefits of new machines without necessarily going to the real world. In the context of energy, that's also another area where you see the use of powering motoring systems, where digital twins are enabling operators to predict the possible future state and provide solutions in time before power systems failure or emergency would occur. It also helps to kind of visualize the management of underground pipe networks where humans cannot physically be, and also helps to visualize the three-dimensional operation guidance system. A very interesting area where the digital twin is being used and very helpful is in the health domain. Now in healthcare, you can use this to simulate virtual organs, and also in cases where you have to do computer tomography imaging and cardiac catheter interventions and so on, scanning and all sorts of surgeries. Now you talk about robot-assisted surgeries, you talk about the Da Vinci systems, and in digital surveillance, where digital twins can be helpful in the front for monitoring health condition of patients. And also we have the health infrastructure where digital twins can be helpful in constructing conditions and simulate conditions, and also in the use of drones, delivering medications, delivering and supplies to hard to reach situations. And then we'll look at another example of digital twins in petrochemicals, where people do virtual visits, the digital workspace visualization, and so on. So these are some of the areas where digital twins have gained a lot of prominence. But now let me zero down to our area of interest, which is agriculture, and to look at the applications and benefits of the digital twins in the agri-food system. So we first say that the use of digital twins will help actors along the agri-food system to better understand the operations and processes required in different agricultural activities. Secondly, the actors can use the virtual systems of various applications of digital twin to simulate the performance of various farm inputs and growth parameters. And digital twins will provide enormous opportunities for experts to actually provide technical supports and to also see what are in the other value chain actors remotely, especially when you go into the use of drones and drone technologies. Now, we'll also speak to the issue of smart farming, where you see drones being involved in the use of modern technologies and in various farming activities to reduce the amount of agricultural inputs while increasing efficiency and productivity. We also see here that the use of the digital twin technology is intended to increase agricultural production with minimal use of farming inputs, which is a necessary and sufficient condition for the transformation of our food systems. So when you look at the Nigerian example, Nigerians are now using digital twin technologies, especially in the areas of tomato cultivation and gathering artificial intelligence and information from physical greenhouses to be able to see how they can manage the resources that are being deployed. So another area where you have these is in the area of irrigation, where you can actually use digital twinning applications to enhance the resource use, especially water. In the context of climate change, you can actually use the digital twin technologies to monitor the use of water, the flow, the consumption, and so on. You can also generate a cyber physical system using the digital twin technology, which can be developed for managing farming system. Livestock is another area where we think the use of digital twin can be very helpful, using this to collect data in terms of the animals, where they are moving, where they are grazing, managing fodder and further productivity, managing the use of how the animals are moving and the productivity of the animals, milk production, calving intervals, and all of this. So the digital twins really offers promising solutions to really help the development of the livestock using sensor-based transponders that are put on animals that can be helpful in the productivity of these animals. If you are doing ostrich farming, if you are doing, it doesn't matter. All of these can be harnessed within the context of Internet of Things, and this is what digital twinning is all about in agriculture. And I would also now go into a little bit of crop simulation and the crop model, where the use of data-driven predictive modeling of weather and soil moistures and or what we call, where you can have early warning predictions and modeling of weather and modeling of yields that can help you determine also futures, the yield, market infrastructure, market availability, and all of this. So the feasibility of digital twin in monitoring the cycles between growth is also quite important. And then in food processing, which is one area where we need a lot of effort, knowing that we lose up to 40 to 50% of our products post harvest. Digital twins can be applied in preserving our produce, especially when you are using solar drying, to be able to avoid scenarios of under drying or over drying. And it can also be used in the integrated physical system of physical dryers, and to also determine the relevant kinetics of heat in the course of post-production exercise. I'm also going to look a little bit into the robotics and the automation of equipment, artificial intelligence. This is important, especially in the context of precision farming. When you look at industrial automation and agricultural robotics, the concept of full digitalization and production equipment can leverage on digital twin technologies to be able to achieve the interconnection and connectivity between equipment and the management of resources in the production system. What are the challenges we have in Africa? Quite a bit. One is the human capacity and the experience to be able to engage machines and machine learning. Limited infrastructure, as you can see, that this digital infrastructure will definitely be power intense. So energy is one area where we need to keep an eye on. Another area is where we see the difficulty in accessing data and the high cost of implementation of digital twinning in the context of the African scenario, and the low predictive power of digital twin. For example, we didn't expect that there's going to be shortage of grains in Africa because of the Russia-Ukrainian conflict. It could not have been foreseen, but digital twin will not accommodate all of those things. So therefore, that's one of those. These are some of the challenges that we can keep our eyes on in the context of digital twinning. Now to a few recommendations for Africa. We need to find a possible way to pilot digital twinning and then to create digital twins agricultural platform. We also need to have the enabling policy environment that governments can support public goods in the area of digital twinning, and then to facilitate research collaborations that will help to create the opportunities in the agricultural sector for collaboration among local researchers from the academia, from the private sector, research institutes, the industry, and to be sure that we all have a holistic approach to the integration and use of digital technologies. I now close, ladies and gentlemen, with a few points and conclusions. One is the concept of digital twins and its application in the different sector of development as well as agricultural food systems have been presented. We need to have several applications of digital twins, including the smart farming, livestock, food preservation and processing, agricultural robotics and equipment automation, crop growth models, agriculture and food processing that have been identified and discussed. Then we need to see the benefits of the challenges of the digitalization in African context, which must have also been presented in the course of this short presentation, and what we need to do towards the adoption of digital twin platforms on the continent. Lastly, we will then be looking at how to take full advantage of these opportunities, and then governments need to show the commitment by creating the enabling environment. There is an urgent need for us to train scientists and their expertise in the digital twinning context. Ladies and gentlemen, my time is up, and I thank you for yours.